Today's topic is IoT for small and medium-sized enterprises and manufacturing. A brief introduction about Sumanji. Sumanji is an IT strategist and leader with career span of 35 years and experience and exposure across varied industry segments. Over the years, he has been associated with reputed organizations such as UPL, various profiles, Anna Reports and SEZ, Tata BlueScope Steel, Tata Steel, L&T and L&T India.
Rajeshji, thank you very much for introducing. One point actually I would like to mention upfront that whatever I am today is because of Mr. Harish Pathak, and he has given me opportunity to work in IT, and without him I would have not come to the stage. So that's very interesting. I start with that. I am really humbled that Mr. Pathak has invited me to speak to the August presence of all of you. So I will start the presentation with a small thing. That is, you know that today everybody of us know what is internet, and everybody are using internet, living internet. Without internet, we cannot do anything. So if I ask a fundamental question, what is internet? What actually we understand from internet? So internet is actually connection of different servers, because there are some amount of data kept in some server, and those servers are getting connected using some network, and that is internet. Now this internet, using the servers and using the devices we are using to connect the server, we have been successful in connecting all of us among us. So internet is so successful because everybody, whoever we talk, whoever we are related to, we are connected among ourselves. Now if we take this conception of connection between people, if we take it little further and we think that we will connect the things means it may be inanimate object, but if we can connect them using our internet connection, then we say it is Internet of Things. So the question what today is rising, that what additional thing, what additional benefit or what additional impact it will have in our life. So I'm just saying a hypothetical situation. This slide I have taken from one of the Gartner presentation. What we are saying, imagine that somebody is sleeping early morning in his bed, and he knows that he has a office to start with at 7 o'clock in the morning. Now, for some reason, suppose if all the item which he has to use for the purpose of his daily dincharya, if they start talking among themselves. So suppose he comes to know that his train is running 20 minutes behind schedule because there has been an accident on the driving route, and therefore automatically his car knows that he has to fill up a gas, and therefore it has to go to the train station before that, and then he actually also knows that his meeting has been pushed back by 45 minutes. Automatically that will actually set his alarm by another 5 minutes. He may get another 5 minutes more sleep. It is showing some hypothetical situation, but this is what is going to happen in days to come. In very soon, it will happen when your refrigerator will start talking to your smartphone, and it will also start talking to the counter, the hypermart or DMart counter, where they will know what are the things to be picked up. Now, what actually it means? It means IoT has got three important parts. One is information technology, one is Internet of Things, another is most important, which is more important for the manufacturing industry, is industrial information of things. Now, in that, there are two areas primarily. One is the industrial area, another is the consumer area. In consumer area, almost all of us have been seeing IoT for quite some time. We are using wearable, we are using phone, smartphone, we are using television. There are n number of appliances in our home for the home monitoring, for the home automation, and for the purpose of other activity. But in industry, to some extent, the IoT has not gone that level in India. Yes, in some sectors, definitely it has gone. But in manufacturing sector, it is really yet to go in that depth, but it is slowly coming. So in industry level, there will be heavy machinery, transportation, smart cities, automation, factories, healthcare. They have started seeing some amount of IoT activity. So what is that IoT activity? Now, so this is actually the fourth industrial revolution which is coming to us. The first industrial revolution, we have actually seen there is a lot of mechanical activity, mechanical machines and production facilities came into place. In the second industrial revolution, we have seen that there is a using a large amount of electrical energy. They have put the second industrial revolution. The third industrial revolution, which started around 1970s, that was most of computer, electronics, and IT system. And the fourth industrial revolution will be the completely digitally connected world. This slide I have taken from a company called Beckham Research. Beckham Research is a company who does the research work on many of the IoT related things. Not only IoT, they are basically a IT research company. But this slide, what it shows that almost all industrial sector, whether it is building in a building, energy, consumer, healthcare, industrial, transportation, and if you go one level below, then there will be some area where there will be appliances in the bottom. After that, there will be some kind of software or some kind of system, and there will be some services. And all of them are getting connected by the IoT actually. What I was actually trying to show that today the manufacturing industry is changing so quickly. The supply chain has to be much more modern compared to what supply chain used to happen earlier. The production facility has to happen more modern compared to the production facility we had earlier. And in that film, it was shown that those adoptions are directly coming from the nature, because in nature, if you see, wherever evolution has happened, there has been a lot of effort taken by all the animals, all the species to adopt for the new changes, and that exactly our industry is happening. Let's go back to the market side. So this data, it shows that today by 2030 24.1 billion IoT connected devices will be in place, and if you see from the revenue perspective, they will actually become 1.5 trillion revenue. Now, many of us, I know that it doesn't hit us, because when we look at our our neighborhood, or when we look at our industry, we don't understand that how much changes slowly is happening. So if you see in these 24.1 billion areas, many of these areas, inventory management, asset tracking, lighting, connected vehicles, they are actually concern to our manufacturing industry. Today, the penetration is very less because of the non-availability of the sensors at an affordable price, and because of also the non-availability of the reliable internet connection everywhere. If these two things are taken care of, you can imagine the total number, how much it will increase actually. Let me come back to the next data. So in the global IoT market, if you go to the share by subsector, the maximum IoT is done by the smart cities. And now our own Pune, when they are going for the smart city, they are also planning to introduce lot many IoT devices so that the city can be more smart and give the amenities to the citizens. Then the next sector, which is also a very big consumer, is the industrial IoT, which is the sector where we generally work. Connected health, smart homes, connected car, wearables, they are coming slowly others after that. And it is actually expected that by 2020-25, there will be around 411.9 billion US dollar. That spending is expected just by 2025. That is going to come actually in this area. Now I have actually prepared this slide. This I took out from Forrester. Forrester has published a wonderful report that what are the areas which are in one area. They have shown what are the areas which are important for the industry and which industry is taking help of that. And they have prepared a heat map. Heat map means wherever you are seeing the blue color, it is cool, means the IoT penetration is less, and wherever there is red, it is actually hotter. Hotter means it is actually the highest penetration has happened. And accordingly, they have prepared this graph, and I find it very fascinating, because two area where actually is my focus. One is industrial asset management, and another is actually if you come here, energy management. The IoT penetration is quite high those areas. With IoT, what is the future of manufacturing? 60% global manufacturer will use analytics, data track using connected devices to analyze and optimize the process. And 70 billion US dollar would be invested by manufacturers at industrial IoT by 2025. And then there are other data actually. Now, what does it mean for us? So I am actually I just wanted to bring to the discussion to what we can see in the manufacturing area where IoT is created a difference. So I will say there is a digital connected factory comes into the top. So digital connected factory means there are factories. Inside factory there are machines which are connected, or there are factories which are connected digitally with them, and by which you can improve the productivity, you can improve the maintainability, and you can also reduce the cost. Then the next area which is very important is facility management. So in manufacturing sector, if you know, facility management plays a very important area, because in facility management, whether you are managing energy, whether you are managing administration, whether you are managing your power supply, everything comes under facility management. And IoT for manufacturing is playing a very important role in that area. In one of the projects, I just give an example of facility management. Then the next important point, which is very important for all of us, is actually production flow monitoring. Because you need to think that unless and until you have a successful way of monitoring the production flow, it is very difficult for actually finding out how your supply chain is being planned actually. Then the fourth area where IoT for manufacturing is teaming up is actually the inventory management. Because in inventory management, what we actually are doing today, any one of us who has worked in manufacturing sector, we know that stock take is a very huge activity. Particularly if you are working in FMCG, or if you are working in pharmaceuticals or in agrotech company, wherever you are working, you will find that there are small inventories, small SKU, and you need to take a stock take activity to synchronize with SAP. What is the data on ground vis-a-vis what is the data on the SAP? So inventory management plays a very important role using IoT. Plant safety and security is another area where IoT for manufacturing is very important. In quality control, there are some area, there are some industry or some sector where are extremely quality conscious. They cannot allow even a small amount of deviation from the parameters, particularly if you work into the pharmaceuticals area, and IoT is playing a major role there, because you are putting sensors in those places and they are actually giving you data as per required. Packaging optimization, and then logistics and supply chain optimization. I think all of you may be aware that in the whole supply chain, managing the transportation or managing or organizing the material which is to be built, which is going to the transportation, that becomes a big headache. And therefore, IoT plays a very important role there actually. And the last and most important area is the predictive maintenance. Because in predictive maintenance, what we do, we actually before going ahead of the any breakdown, we actually monitor that the machine has a vulnerability of any breakdown, and you actually predict, and accordingly you save the production time. Okay, so far whatever I have said was actually about the application. Little bit amount of physics I will come actually, because there is something called cyber physical system. So what is cyber physical system? So many of you might have heard the word called physical. The word physical is actually a joint word of physical and digital. That means you have a digital store, but you don't buy from digital store. Before that, you actually go to the physical store, see the physical product, come back to a digital store, buy there. That's what is our normal behavior. So the same conception I am bringing back to the IoT scenario, where we say that cyber physical system. So IoT scenario, there will be a system where the computation will be done in the background, and the communication and control are actually for the physical entity and digital entity. So what will happen? Cyber physical system will be a system which will have a unique collaboration between all these three areas. And what will happen in that case? The advantage is they will allow us to add capabilities to the physical system by adjusting, by computing and communicating to the physical thing with the digital area, so that your cyber physical system works as the total ecosystem of the IoT devices. Today's factory means factory where IoT is not there. We'll have the workstation which are actually serial. So one workstation, one work will happen, then it will go to the next workstation, then it will go to the third workstation, and finally the car will be made. And if there is a IoT enabled workstation, you need not go in that serial, because you will understand what is required. Every machine is talking to each other. every product is talking to each other. Whatever has to be inventory has to be collected, they are also talking to the production system, and therefore you can have a much shorter duration, much lesser inventory to produce the same kind of end product actually. So this is what is the benefit of the IoT when it will come into the manufacturing industry. So typically when you're implementing a IoT solution, there will be at shop floor, there will be sensors, and those sensors will be connected with some kind of network connection. This particular item will get connected to a switch, then they may go to a server, then they may go to a firewall and to internet. And in the process, all the machines will be connected. So this is typically a schematic diagram, a very raw schematic diagram of IoT. IoT diagrams are not so simple, but I have just made a raw diagram to explain. And then the next process is what are the main building blocks. So in the, the main building blocks, if you say, there are many. The autonomous robots are there, on which you people are working very good job actually. Big data analytics is there, augmented reality is there, adaptive manufacturing is there, cyber security is there, industrial Internet of Things is there, and simulation is there. So in fact, many of the cases, the IoT system and the AI are actually working very closely so that they can create a near life experience, and all the connectivity and all the industrial implementation can happen easily. So what I wanted to show, what are the sensors and what are the hardwares we are using and the second part of the presentation I am showing what are the chips we are using for doing that. So there are many sensors. There are moisture sensor, temperature sensor, motion velocity sensor, position sensor. Then there is optical ambient sensor, acceleration sensor, electric sensor, and the chips what we are using is, it may be Raspberry, it may be Arduino, it may be Adafruit range. Those chips are actually used for the purpose of taking data from the sensors. Let's go back to some of the framework. It is important for me to mention the framework because I am a CISA auditor, and first thing first it comes in my mind. So what actually I wanted to say, I'll just say for instance, you have a company, your turnover is let's say 100 crore. And in that 100 crore turnover, the question comes, somebody has come to you and said that, you know something, you can do wonder if you implement IoT. So you need to think, when you implement IoT, what are all areas you need to think? What in my opinion, this ISACA COVID document shows us the fundamentals are still there. Actually, you need to show what is the strategic alignment with business, what are the value delivery you are going to do, what are the risks you are going to come into, and how do I managing the resources. So if we go to the little detail, this is a slide which is from a live customer. So we actually prepare a 10-point scale, a hexagonal spider chart, and we find out that where business is wanting to work. Because for that company, it was regulatory, location, relationship, quantity, pricing, packaging, and product. Now, where is the focus of businesses? And accordingly, we need to plan where IT has to spend. In the next graph, what I have shown, one company, they have actually spent IT, competitor A, in many areas. And one company, they have made expenditure more in these area, but you see the business have the focus in this area. So even if they made IT investment in this area, they may not be able to gain much because they are not aligned with business. So this kind of spider chart needs to be done before you take any IT project, specifically IoT project, because IoT projects are very, very vulnerable to failure. And when they fail, you cannot go back and rebuild because that will actually remove your profit altogether. So this kind of alignment check, this kind of risk management check needs to be done before you take up any of the IoT project actually. So my suggestion for small scale manufacturing industry, with some of whom I have spoken very recently in past 1 or 2 years time, we need to actually define the key areas which will give the maximum benefit by introducing IoT. So if you really see, there are some activity which happens in factory, some activity which happens in your marketing area, some activity which happens in finance area. Now, you need to implement IoT in 3 different areas separately, or one project which has connection in all 3 areas where the main benefit will come from the day. Then in each process, you need to understand what are the KPI, KRA, and how much improvement is going to come. What kind of architecture we are thinking? What are the data points? Because if the data points are wrongly chosen, it will give you wrong result actually. Then you need to be very careful about the choosing the sensors. What is the source? What kind of sensors you are choosing? Whether they are actually suitable for your kind of business, whether they are suitable for your kind of environment, whether you have the security system to maintain their health of those sensors. Then we need to choose a very proper IoT platform. We need to identify the security risk and vulnerability in each step, plan global, but implement in segment. Because in case like all IT projects, IoT projects are also taking in the agile mode. You design the sprint. Sprint is a 2 weeks program. In that 2 weeks, we call it sprint. Divide the project in different sprint. I achieve in the sprint. Change, see what changes you need to do. Implement those changes in the next sprint and then go ahead. Realize the benefit and then take the next step. Now, I have actually, from my experience, have written what are the business problem for a manufacturing sector. Like for instance, and then what is the presently you are doing the solution and what solution you can do using IoT and what benefit you can do. For instance, I'm just giving an example which can be, these are all low hanging fruit, which can be done immediately. Security of your office. Today, maybe you are doing by the front door lock, by padlock or CCTV for surveillance. If you go for IoT smart lock or if you go connected camera or integrated car, your transparency will be much better and your manpower requirement will be less actually, where the IoT can create improvement. So three projects which I just we just say that all companies can do, but I had little exposure to do that. One is the traceability of inventory in real time. It is actually a very low hanging fruit. People can do in the manufacturing area and create much benefit out of that. So I'll give you a small brief example. This inventory management project was done in one of the paint industry where I was associated. So we had to put the barcode sticker in each item. We put the some kind of matrix of the location, and we also use a app for scanning and make an application which will track the item. And we use for FG as well as the for the some kind of semi-finished products as well. So this is some kind of inventory management project, and this is one product which actually I have done in bits and pieces. But yes, in the full part, it is a big project. You can actually do a complete maintenance, predictive maintenance through the connecting devices, which actually will give you the data on the production, yard management, everything you can do like that. This is a major project, but some part of that has been done in some industries and they are giving good results. And then lastly, the project where I am now working, which is actually some kind of global track and trace project for an agrochemical formulation line. I have given you some bits of pieces of line photograph. In those lines, they put lot small bottles, in some case jars. Bottles go into the packet goes into the shipper goes into the crate goes into the pallet, and pallets are dispatched. And we need to do some kind of complete track and trace in conjunction with the ERP system, and it has to be the track and trace has to be done till customers end actually. So we have achieved that. Currently, this project is being done. So what we have done, we have actually done some kind of 4 levels of automation. There is a level 1 automation where we have put all the PCs, PLCs, and all these things. There is a level 2 software we have developed where the optimization is done. There is a plant level C software where we take out the packaging data, the filling data, and do the some kind of MES activity. And then there is a level 4 software which actually do the integration with SAP and gives you the what are the process order number and all those kind of things. And then finally that goes to the external system actually. And some of the photograph I have added, like today, there is a live photograph of last night actually. They are doing go live in Brazil, so it's a Brazil's photograph. So they are using some handheld terminal, straight away go to the particular item, particular trade, just scanning, putting the data there, and they are getting the OBD, getting the dispatch data, the GR data, and those kind of things. And the dispatch is happening actually. And the another project, where I am not directly involved, but yes, it is being done, and I am little bit aware of that. So I'll just show you. I don't know whether you are actually hearing the sound, but if you can read the screen, you can see what they are doing actually. So this is important slide. I have told all good things so far because everything is not good when it comes to implementation. Projects fail and why they fail. So in name of IoT suppliers implement old technology. This is one of the major threat today because there is no knowledgeable person in the organization. They can't differentiate what is the latest technology, what is the old technology. Then you can design the business process does not include a realistic work process. That's a problem. The project will fail. There is insecurity or fear in the shop floor people and sabotage happens. I have seen sabotage happen in many companies, particularly in Viraj. I have seen that. Selection of sensors being wrong actually goes project out of budget. Cost escalation because of prolonged project life, change control issue, and then another area when you are bringing IoT into the manufacturing process, you need to plan very strong operational technology security or plant machineries IT security. So if that is not taken care, then project may fail because there can be a ransomware attack, there can be some kind of malware attack, and the whole production facility can go down, and then attrition of the key members.
In automotive sector, they have got a AutoSer platform, which all the SKUs are all the missing sensors are coming in the same platform. So they are able to, the vendors are able to move around the auto manufacturers. But coming to industrial IoTs, each sensor is working in its own platform. So each one, the failure rates of individual things are different. After that, the companies become weak and one merges with the other company, one doesn't exist overnight. So how to come out with this? The implementation of 4.0 and the more and more IoTs, it is becoming a headache, or it is more pushing the promoters towards conventional systems are better reliable than these things. So how to
Yeah, yeah,
go?
yeah. I appreciate the point you have put forward. This is a problem. So particularly today, one of the that is why I told that the roadmap when we design the architecture in such a way that we actually plan the sensors which are of the same family and that interconnectivity is better. However, there are a organic growth of the company happens. The company with whom I am working now, they have a plant in China and they just acquired two plants in China and those plants did not have they had separate kind of sensors actually. Now in reality, it is very difficult to change the sensors or change the system because then the cost of the IoT project will be so high, it will be unviable actually. So what we did under that situation actually, we did a study and found out a gap analysis and what kind of bare minimum changes needed to make that compatible we did actually. In automotive sector, I am sure what you are saying is right because in automotive sector there are different kind of, in fact it is a museum. If I say use the word, it's a museum. Different kind of suppliers, different kind of vendors, they put their sensors, all these things. But if you can design, there are some organizations, again in public domain, I don't want to name, but there are some organizations who are helping us to design that kind of interface between different sensors and how to put those sensors data in a common platform, and that is actually helping us.
Sir, as an additional question to this, when we are trying to adapt the IoT systems or industry 4.0 system, what is the maturity level at which point we can try to automate the system? Because if the system, as you said, if the employees are not trained properly, there is a failure possibility. And to avoid the failures, they make the product damage, they sabotage the product and put the blame on the product instead of taking a failure in their own name. So these kind of things, the maturity of the system to absorb the adoption is more important. So how do you assess that, whether the factory or the particular progressive manufacturing unit is ready for adoption of IoT?
So I can give one example to that. Again, that agrotech company with whom I am working, we have implemented something called a command and control center. Command and control center is actually a very ambitious project for that company, where entire plants, machineries, SCADA, everything is connected to Bombay actually. And in Bombay, we can see what is the output of the particular plant. We can also see what are the type of control we need to do that, or in case some tweaking needs to be done, we can see from Bombay. We have implemented that. We are in the process of implementing, maybe in two areas, three areas we have done, but the entire India has not yet been done. What problem we face there actually? The first problem is that those sensors used to be, they created some kind of fear in people's mind that if these sensors are there, maybe our super boss will also see what we are doing in the shop floor. So they used to damage the sensor, imagining the sensors are camera actually. Sensors were not camera, they were just sensors. But something has come there, they used to imagine that this is a camera and boss will see through CCTV what we are doing, they used to damage it. So what we actually did that, we observed that for quite some time, for almost for 6 months, we did not make any headway because they used to damage the thing. What actually and there were a lot of HR initiative, lot of campaign used to be done, but nothing worked actually. So what we incidentally we did, those sensors, whatever we were putting, in fact we put some kind of IP76 protection, all those kind of things. Nothing worked actually. What we actually did, the people, the shop floor people, we chose a group of people from the group, from the community, and made them responsible for implementing that portion actually. And we told them that your KRA is depending upon this. If you are implementing this successfully, you will be getting this point for your next year appraisal. That actually helped. But in different organization, you need to do different kind of technique, because in the steel company where Viraj I used to work, nothing worked actually, because those people are steel people. Steel people are not at all sophisticated people. Many of you who are informed from the steel market, they will understand. So for them, we used to use in Viraj, we used to use, the threatening way. Again, nahi chalta hai na, this month there will be no salary for it. So it is different actually, but yes, that's a genuine problem we face actually.